So now we'll look at a convexity mispricing. You recall the way convexity worked. And let's, so here we have three prices. We have strikes of 50, 59, and 65. And you can see that as the strikes increase, the call premium goes down. So that's logical. We know that the call price should drop as the strike goes up. So let's do a graph as we're doing this. So we have our call function here as a function of strike. And we have strikes of 50, 59, and 65. Now, what we expect is that the price at 59 should be below the interpolated value of the prices at 50 and 65. Right? That's what the convexity assumption meant. It said that the price at 59 should be less than or equal to, I'm going to have a weight of 6 over 15 nope, 6 over 15 times the price of 50 and a weight of 9 over 15 times the price at 65. All right, so we're closer to 65. We put more weight on that price. So this price should be less than 6/15, which we can also, of course, express as 2/5. So, and then the question is that the case? Well, when we look at this example, turns out it's not. That the price of 59 is $8.90, and if we looked at the call premium of 14 and 5, this would be 14 and this would be 5, so this would be 3/5 and this would be 2/5. So we would get, has to be less than 3 plus, and this would be 28, this would be 580, which would be 880. See if I did that right. This would be 28/5, which would be 5 and 3/5, 560, so it would be 860. So it should be no greater than 860, and we see that in fact it's 890. So it violates our convexity assumption, and it's too high. So by doing this calculation, we immediately know what the problem is, that the contract, the 59 strike contract is too expensive. So what do we want to do? Well, we want to sell them, and we need to buy the others. And the basic idea is that the number of contracts we need to sell and buy correspond to the interpolations that we saw in the prior. Namely, that we basically want 6 of the 50, 9 of the 65. So if I go, what that means is I want 6 of the 50 contracts, 9 of the 65 contracts, and I should sell 15. So you can see what the author did is just a scaled version of this. The actual weights in this trade come from the weights in our diagram. And you can see that instead of selling 15 of the middle contract and buying 9 and 6 of the end contracts, the author simply scaled each of these positions down by a third. So 6 went to 4, 15 went to 10, and 9 went to 6. But you could implement this either way. It was natural to illustrate this with the lowest common multiple. And in fact, you could cut them all in half and do 2, 5, and 3. So clearly, multiples of the pattern work just as well. And then you see an arbitrage here where you carefully go through and say, what if the stock at time t is in the various places, and then you need to carefully trace that through, and you will see that in each case we have an arbitrage. Notice that we had to lend money here. We invested $3, and that we're going to get interest on that. And then the arbitrage at time t, in each one of these situations, we have some additional money. This is another example where we have a mispricing. So on the second convexity mispricing for a put, we can look at this price of 8 and again determine that it's too high. How would we do that? Well, the price of 55, it's a put, should be no bigger than, I need a weight on 4 and a weight on 16. The weight on 4 is 3/4, and the weight on 16 is 1/4. So I get 3 plus 4 is 7. So according to convexity, the put price of the 55 strike should be no greater than 7. As we can see, it's 8. So we're going to do the same thing. In this case, you can see that, again, we sold the contract because it's too high. But we're going to sell 4 of them and buy 3 and 1. And again, the 3/50s comes from the weights right in the equation.